In this video, we'll talk about how element-wise and broadcasting operations in NumPy. Let's get started. In NumPy, the operations, the mathematical operations are usually done on pairs of an array, and that is element by elements or like an element-wise basis. In the simplest cases, you can consider that the two arrays must have exactly the same shape. Remember that they need to have the same structure in order for them to perform the element-wise mathematical operations. Say, for example, here we have two arrays. One is the x, and then one is the y, and then x is the 1, 2, 3, and y is another vector that is 2, 2, 2. Now you can see that what I mean is about the element-wise operation is that here, because they have the same shape, here we have the two vector here, so they will take the first element out and then do the mathematical operations, that is 1, 2. And then they will take the second elements out, 2, 2 here, do the multiplications that give you a 4. And similarly, we have the 6 at the end. The term broadcasting describes how NumPy treats arrays with different shapes during mathematical operations. In the element-wise, we just mentioned before, we need the two arrays have the same shapes. But broadcasting actually relax these constraints if the array's shapes meet certain constraints. And of course, subject to that constraints, the smaller arrays is broadcast across the larger array so that they have a compatible shape. And broadcasting is very important in deep learning. It's mainly because it provides a means of vectorizing an array's operations so that looping occurs in C instead of the ply form. The simplest broadcast examples occurs when an array is just multiple with another scalar value. So for example, here we have an example. We have an x, which is a vector, 1, 2, 3, and then we try to multiply by 2. Here you can see that x is actually, for each element of x is actually multiplied by 2. That means these two is, this smaller arrays is broadcasted to these larger in the arrays to do that multiplications. 2 plus 2 multiplied by 1, 2 multiplied by 2, 2 multiplied by 3. And then we got these vector. Let's go through these rules by some example. And of course, you can always refer back to these Jupyter notebooks to see these rules. Again, we first create an A array that is 2 by 2, and then we create another array that is just a one dimensions vector B that is 2 elements inside that. And then if the arrays do not have the same rank, now they do not have the same rank. So what we need to do is that we will prepend the shapes of the lower rank with 1s. This is the lower rank, that is B, with 1s, so that until both have the same length. By what I mean prepend is that we add a 1s at the very left-hand side of these B array. So now we have a 1 by 2 in the array. We have another 2 by 2 in the array. Now the two arrays are set to be compatible in the dimensions if they have the same size in the dimensions, or if one of the arrays have size 1 in that dimensions. Now they do not have the same size in dimensions, but because one of the arrays has the size 1 in that dimensions, this is the size 1 in these dimensions. Now they are compatible in these cases. And then because they are compatible, the two arrays can be broadcasted together. And what I mean by broadcast is that you can see now I just try to use additions or sums for these calculations. 1A plus B. By broadcasting, what I mean is that each arrays behave as if it have the shapes equals to the element-wise of the maximum shapes of the two input array. And here, this is the maximum shapes. This shape is larger than this one. So we just consider it just as if there's two B here, they're stacking to each others. So what I mean is that this is just like the B, another, let me bring you another B. It's just stack together. Something like this. And then these two arrays are stacked together so that it will give you a 2 by 2 matrix or 2 by 2 ND array. And then for this one, this is the first row, 0, 1, and then it will just pass the first row, 4, 5. And this is the second row, 2 by 2, 3, and it will just add another 4, 5 here. So at the end, you will get the results just like this. So this is what I mean by after broadcasting, each array behaves as if it has the same shapes equals to the element-wise operations or element-wise maximum of that shapes of the two input arrays. In any dimensions where one array have size 1 and the other array have size greater than 1, the first array behave as if it were copied along that dimension, just like what I did in here. So it would just copy along with these dimensions to make these shapes to become 2 by 2, so that A and B are now compatible in these cases. Now let's take a look on the other example. Now we have an A that is a 2 by 2 by 2 ND array. And then we have another vector again. So if the arrays do not have the same rank, just like what I mentioned before, we are going to prepend the shape of the lower rank array with ones. So we are going to prepend this B with ones. So we got 1, 1, 2 here. Now we said that these two arrays are compatible because one of the arrays have size 1 in that dimensions. So we got 1 here, and then we got 1 here, and then for these two, they are in the same shape, or they have the same number of elements. Now the array can be broadcast together if they are compatible in the dimensions. Similarly, we can just do the calculations. And you can see after broadcasting, the arrays behave, the resultant arrays behave as if it had the same as the shapes equals to the element-wise maximum of shapes of the two input arrays. That means it just have the same shapes with the A, that is 2, 2, 2, 2 by 2 by 2. And then, of course, it will perform that element-wise additions, just like what we did before. So 4, 5 plus 4, 5 plus 4, 5 plus 4, 5 plus 4, 5 here. So at the end, we will get a 2 by 2 by 2 matrix, and then we perform that broadcast operations. Now let's visualize a bit on what we've done here. At the very beginnings, we have a 2 by 2 by 2 matrix, 2 by 2 by 2 ND arrays. So that means we have two matrices, they're stacking together. And on the other hand, we just have a vector that is 4, 5. And we need to first of all, we need to expand these shapes because they are not matched with each others. In that case, just repeat what we did. If the arrays do not have the same rank, prepend the shapes of the lower rank with ones. And then now the two arrays are set to be compatible. We just check the compatibility, whether or not they are compatible. Now they are compatible, so of course we can continue to do that broadcast. Now because they are compatible, it's just like you stack these 4 5s together, 4 5 and 4 5. Now you can see that these two shapes are compatible, and that means we can perform these additions operations. And 4 5 plus we have the shapes on the left hand side that's 2 by 2 by 2, and then again we just do another extensions. First we extend one of the rank that is 2 by 2, and then we extend another rank that is 2 by 2 by 2. That means we are going to copy these 4 5 4 5 2 by 2 matrix into these brackets here, so that we will have a shape 2 by 2 by 2. Now, because we have two shapes that have the exact same shapes, that means we can perform that element-wise additions, and at the end we will get these 2 by 2 by 2 matrix with these element-wise additions operations, 0 1 plus 4 5, 2 3 plus 4 5, and so and so. Just like what I mentioned before, broadcast provides a means of vectorizing arrays operations, so that loopings would not occur within the Python. Instead, it will happen in the C to make the vectorizations, or to make that loops much more efficient. And that's it for these videos. In the next video, I will show you how to perform some aggregate and statistical functions in NumPy. See you in the next video.